Nomenclature. There are many common names for aromatic compounds, and because the history of the aromatic compounds is, predates IUPAC and organized nomenclature, many of these common names are used, and they have become, as your book says, they have acquired historic respectability, and IUPAC recognizes them. So we have to memorize these. This is benzene. Toluene is benzene with a methyl group on it. Cumene is benzene with an isopropyl group. Styrene is benzene with an allyl group. Phenol has a hydroxy group. And these guys, we haven't really learned how to name these groups. Anisole, benzaldehyde, acetophenone, benzoic acid, and aniline. I'll just, that's going to take too long. I'll put pluses in the ones that are the most important. These are the ones we're probably going to run into the most, the ones with the pluses in them. And so if you're not able to get them all memorized, you should get those. Oh, we should add benzoic acid in there. That is important too. And here are some others. These are monosubstituted benzenes, meaning they just have one substituent. And these are ones that do not have common names. And so we just name them like we've been naming other things with the base name benzene. And they don't need a number because all of these carbons are identical. And so this is bromobenzene, chlorobenzene, nitrobenzene, ethylbenzene, and propylbenzene. Things get more interesting when we have two substituents. We have to indicate where they are. There are two methods of doing this. The one your book seems to prefer is ortho, meta, and para. So these prefixes tell us the relationship between these two substituents, and this diagram is very helpful. If you put one substituent on the top position, then you need to look where does the other substituent fall. If it's on just one to the right or one to the left, that's ortho. If it's two to the right or two to the left, it's meta, and if it's all the way across, it's para. Now, another book that I taught out of called this X1 capital P. They said that's your principal one. And so if you call that principal, then this spells the word pump, P-O-M-P. And so that's one way to remember which one's ortho, meta, and para. So this is your principal one, and where's the other one? Ortho, meta, or para. Meta on this side or that side is the same because if you just tipped the molecule, flipped it around, you'd have exactly the same molecule. So what these abbreviations do, O, M, and P, these prefixes, they just give the relative position. You make one of them carbon number 1, and the other will be in one of these positions. We can also use numbers, and that happens as well. And so this would be 2, and this would be 3, and that would be 4. This is for only 2 substituents. And here's another common name, xylene. Xylene is the common and the IUPAC name for dimethylbenzene. So dimethylbenzene is going to have 2 methyl groups. So if we put them across from each other like that, which of these prefixes would we use? Ortho, meta, or para? Para, because they're across. And so the name of this would be paraxylene. There are 3 different xylenes. There's orthoxylene, metaxylene, and paraxylene. And I believe that xylene is the only common name that you will need to know for a di-substituted benzene.
Could you go back to that real quick?
Yeah.
Sorry.
And just remember, all of these slides are up on OneDrive, and they're also, the videos are on YouTube. And so if you don't catch something, you can go find it later. Yes?
If it's dimethylbenzene, how do you know where the methyl is going to be?
The P. The P tells us where they are. There are 3 different dimethylbenzenes. This is just one of them.
Oh, so you just happen to
I just
pick that one?
I just picked that one randomly.
Okay.
There are 3 of them. And we don't call them dimethylbenzene. So what would the name of that guy be?
Ortho?
Orthoxylene, O-xylene. And there's also a metaxylene, where you'd put this guy would be over here.
Gotcha.
Okay? Any other questions? We use those prefixes even if the 2 substituents, oops, skipped one, even if the substituents are different. So here's one that they're the same. We have 2 chlorines on the benzene, and so this is dichlorobenzene. We use the prefix ortho to tell us that they are next to each other. If we were using numbers, what would we call that one? It would be 1,2-dichlorobenzene. It's really interesting how the different textbooks are different, because some textbooks kind of just mention the ortho, para, meta stuff, but say, well, the numbers are better, and this book seems to prefer ortho, meta, and para, so that's what we're going to go with. Here's meta, or 1,3-dichlorobenzene, and here's 1,4. There's paraxylene. Here we have a sulfonic acid group and a chlorine group. Now, you don't know how to name that yet, but this is just illustrating that this is para, and it applies even though we have 2 different substituents. Here, this one is ortho-bromochlorobenzene. The substituents are different. We're going to list them in alphabetical order. That's a pattern that we've had from the beginning. And ortho tells us their relative position. This one, what we need to do is, I'm going to erase this other name here. When we look at this guy, we might think, oh, well, that's LMN, methyl nitrotoluene. Methyl nitrobenzene. But toluene is a special name. So this guy right here is the toluene. It's toluene with a nitro group. This is styrene, and it has a chlorine group on it. So it's para-chlorostyrene. Yes?
Does the nitro always have the 2 oxygens on it?
The nitro is NO2.
Okay.
And your book is just kind of springing you on that, springing that on you, and I don't like that, but there it
Always
is.
gonna be like that? Just
Not-
NO2 for nitro?
Nitro is always NO2, yes.
Okay.
This guy, this is phenol, and so it's chlorophenol, and these are in the meta position. So they're not always going to be drawn with one substituent at the top. And so you can either turn your paper or redraw it or just mentally think, okay, what's the relationship?
How do you know which substituent takes precedent as number 1?
It actually doesn't matter. So that's kind of nice.
You still want the one that would give you lower numbers? Like,
If you're going to number them, always one will be number 1, yes. But when we say that this is meta, Let's actually look at that, because that's a good question. Come on. There we go. So let's just do chlorine and bromine because they're simpler. Are those the same molecule? They are. One of the ways you can identify if two things are the same molecule is by naming them. If you come up with the same name, they're the same thing. Remember that benzene is planar. It's a flat molecule. And so to take this one and get that one, all I did is I'm going to flip it over like a pancake. And this side is going to come over here, and the bromine's going to go behind the screen and come up, and we're just flipping him over. Both of these would be named meta-bromochlorobenzene because the relationship between them, they are separated by one carbon. There are different ways to think of what ortho, para, and meta mean. And you kind of have to come up with the one that makes the most sense for you. Personally, I like the POMP thing, P-O-M-P. So P for principal, ortho, meta, para. So put one of them at the top, and then where's the other one? Is it an O, an M, or a P? And if I draw it this way, it's still the same thing. So that's why it doesn't matter which one you put at the top or which one you call number one. Any other questions? Yes?
Still want to alphabetize it though, like.
Yeah, if it doesn't have a common name for the first substituent, then and you have to list two, then you'll always list them in alphabetical order. And these rules, they seem really picky sometimes, and they are really picky. But the idea is that everybody can come up with the exact same name, and that eliminates a lot of confusion. It's hard when you're dealing with like a person who has multiple names. The police are trying to track somebody down. He lived over here and he was John Smith, and then he lived over there and it was Tommy Jones. And it's hard to pinpoint who he is and what he's doing and to talk to other people about him because everybody knows him by a different name. And that was one of the problems with chemistry for a very long time, is that all these different compounds had multiple names. They got named in different countries and people couldn't agree. So they finally came together and said, okay, this is how we're going to do it. So we have these rules. And yes, they're complicated, but there's a reason behind it. Any other questions? If you have more than two substituents, then you have to use the numbers. And here are 3 examples. So this one, 1,2,4 trimethylbenzene. This one is 3,5-dichlorotoluene. So here's toluene. If it has a common name for the one substituent, toluene has a substituent of a methyl group on it, then you will give that substituent the number 1 and you will give the others different numbers. So the way that we number this, the only way you can come up with anything is 3 and 5. This one is 2,4,6-trinitrotoluene, and this is what is more commonly referred to as TNT. Yes?
Why didn't they use the number 1 and the second one again, did you say?
Because this is toluene. They're not calling it 1,3,5-dichloro-1-methylbenzene. This is toluene right there. It's toluene with 2 chloro groups on it.
Okay.
Now, my question is, looking at this, I didn't notice when I was putting these slides together, why is this not named as a toluene? I don't have the answer for that right now.
So try.
There's multiple benzene, there's multiple methyl groups, and so maybe that's why, but I guess because one of these would make it toluene, 2 of them would make it xylene, and so maybe they decided for the third one that it would be too confusing to use either of those, and so they're just going to go back to the straight benzene. I don't have a great answer for you on that one. So let's do some examples here. Draw the structure of ortho dinitrobenzene. And as far as homework or a written exam question, if you want to use, I've forgotten the name of it, if you want to use the symbol with the circle in the middle, I'm absolutely fine with that. I prefer it, it's easier for just drawing structures. So ortho dinitrobenzene, we need to start with benzene. It's a hexagon with a circle in it or with the 3 double bonds alternating. Dinitro, the nitro group is NO2. And that's one of those things you just have to memorize. And the book never really presented it very well, but there it is. Dinitro, there's 2 of them. Ortho tells us the relationship. I find it easiest to always put one on the top, even though you don't have to. And then that's the principal, and so ortho would be the next one over. And you could draw it on the right side, or you could draw it on the left side. I prefer to go clockwise. So this is dinitro, ortho dinitrobenzene. How about para-bromophenol? Phenol is one of those special names for a monosubstituted benzene. Do you remember what the substituent is? It's OH. So benzene with an OH group, that's phenol. And you just have to memorize that. Para tells us that it's going to be opposite. It's going to be all the way across. So if this was the principal one, this would be ortho, meta, para, P-O-M-P. So it's going to be down here, and it's bromo, so we put a bromine there. Para-vinyl benzaldehyde. Why did I put that one on there? Well, we're going to have a benzene ring, right? Benzaldehyde. So that would be benzaldehyde. And then vinyl, I have the worst time remembering what vinyl is.
Carbon double bond. And then a carbon single.
Okay. Is it like that?
Yeah.
Nice, this needs an H then, huh? 1, 2, 3, 4. So that is in the para position. This is one of those weird substituents with a special name, vinyl.
Do we need to know that?
Yeah, that was actually in chapter 3. There's vinyl and there's, I think, allyl. That's 3 carbons. On exams, I try not to put more than one or two that I consider, like for nomenclature. I try not to put too many of what I would consider tricky ones. This is one I would consider to be a tricky one. That one's challenging. Now, when you're doing homework, you've got a book, you can go look it up. But on an exam, you have to remember all that stuff, and it's a lot of stuff to remember. Draw the structure of 4-chloroaniline. So these names are using numbers instead. Oops. Do you remember what aniline was?
It's NH2.
It said NH2 on the top. And then 4, we can number to the right or to the left, it doesn't matter. 1, 2, 3, 4. Because this is aniline, that group that makes it aniline needs to be carbon number 1. And so 4 is going to end up being on the opposite side, and it's chloro, so it's a chlorine group.
I thought they always number from
When we're talking ortho meta para, this is the principal one, ortho meta para. But here we're doing numbers. And so this is going to be carbon number 1, where that most important group is. This is 2, 3, and 4. It really would be so much easier if there was only the one system, but there isn't. Now, I pulled these out of your book. They were asking us to draw the structure of 1,3,5-trimethylphenol. And I double-checked on that, and that's a mistake. It should be 2,4,6-trimethylphenol. Because here's phenol. And what position does the hydroxy group have to have? Well, this needs to be considered number 1, because that's the parent compound. And the OH group is number 1. So this is 1, if we number clockwise, we get that. And then the methyl groups will be at 2, 4, and 6. So we'll have a methyl group here, and a methyl group down here, and one over here. Calling it 1,3,5-trimethylphenol would be putting one of these methyl groups in position 1 and spreading these guys around, but then the hydroxy group's going to end up either being 2 or 6, and that's just not right. Okay, let's look at letter F. 4-ethyl-2,6-difluorotoluene. Well, what's toluene? CH3. Oh, I shouldn't do that. They always get so tall. I'll bring it over here. So there's toluene. That's 1, 2, 3, 4, 5, 6. And notice the order here. Ethyl and difluoro. This numerical prefix doesn't count when you're alphabetizing. So we're just looking at fluoro. So ethyl and fluoro comes next. We don't have difluoro before the ethyl. So ethyl is on carbon number 4. CH2, CH3, and then we have fluorines on 2 and 6. Any questions? So we talked about alkanes and alkenes and alkynes, and in that pattern, the aromatic hydrocarbons are called arenes. So they're aromatic, and they are like alkenes, and yet they're not. So they're called arenes. And sometimes we have to name an aromatic ring as a substituent on something else. And so then we say that's an aryl group. And we use AR as the symbol for that. I think my Wi-Fi thing is having issues. Thank you. So just like we used R to stand in for an alkyl group, could be methyl, ethyl, isopropyl, anything like that, we use AR to stand in for an aryl group. Two of these groups have special names. This is the phenyl group. It's a benzene ring, and it's attached to something. So we can name benzene as a substituent. It's called phenyl. And then this is the benzyl group. The benzyl group differs because there's this CH2 group in here between the benzene ring and whatever it's attached to. Now, do those names bother anybody else? They bother me. This one should be benzyl, shouldn't it? That's benzene. Let's just call it benzyl and be done with it. And yeah, this toluenol or something. But why? I don't know. I don't know. So yes, it doesn't appear to be right. But we have to live with it because that's what the rest of the world decided to do. So this is benzyl, and that's phenyl. Sometimes we use pH to represent the phenyl group. We see the phenyl group more than the benzyl group. So like this guy here. We could name this as 2-pentyl benzene, because this is a pentyl group, and it's attached at the second carbon. So that's one way to name it. Or we can name the benzene as a substituent on the pentane. So this is phenyl, and it's on carbon number 2, so 2-phenyl pentane. And it's kind of a perspective, you know. Are you holding on to something, or is something holding on to you? Usually we go with bigger. Which one's bigger? So this could be cyclopropyl benzene, or it could be named phenyl cyclopropane. And here's showing the pH as an abbreviation for the phenyl group. So this is 1,3,5 triphenyl benzene, which if we actually try to draw that out, each of these pHs is another benzene ring.
So it's a phenyl group anytime there's a no line sticking out. I see benzene, and then I see a little, I guess, carbon.
This is benzene, but it's got a hydrogen removed and now it's attached to something.
So hydrogen was removed, attached to something.
Right, it's like taking methane, CH4, we remove a hydrogen to get CH3, and then it's got to be attached to something, because carbon has to keep its valence of 4. And so this was methane, and we call this methyl. It's attached to something. This is called phenyl. I'm sure there's a reason. I really should look it up, but it's not been a real big priority yet. You'll see, drawing all those out, we get some kind of funny looking organic structures there. So a few more examples. And this first one I would never give to you on an exam. Dibenzyl. What do we do with that? What does di mean? Two. Two benzyl groups. Well, how about two benzyl groups attached to each other? Oh, wait. This is phenyl. This is benzyl. It makes me think of Denzel Washington. I don't know why. That would be dibenzyl. I don't like him. But there he is. This one's better. Cyclobutyl benzene. So this is benzene with a cyclobutyl group attached to it. Cyclobutane has how many carbons? It has 4. I think you can probably imagine how you could draw some really interesting pictures with organic chemistry molecules. You can make faces and trains and all kinds of fun stuff. Paraphenylstyrene. You can put pH for phenyl. And then I think is that it? Styrene. You've heard the phrase use it or lose it. Yeah, if you don't use these things, you lose them because our brains get full, right? And we only keep in our brains the things that we're using and that we refer to. So some of these things, I know what they are when I look at them, but then I have not been doing my flashcards. Any questions? Oh, more. Fabulous. Okay, what about this guy? What are the two pieces here? What's this guy? It's a benzene ring that's attached to something, so we could name it as phenyl. And what's this guy? Cyclohexane. So we could call this phenyl cyclohexane. Or we could call it cyclohexyl benzene. How about this guy? What's the name of this part? Yeah, phenol. And then this guy is what? That's benzyl. So, if we name this as benzyl phenol, what's the relationship between these two substituents? Ortho. So ortho, benzyl, phenol. That's going to be the easiest name, because if we put this CH2 group over here, then things are going to get more complicated. We'd rather not go there. I would consider this one to be kind of a tricky one.
So anytime benzene is attached to something, it turns to benzyl?
Benzyl has this extra CH2. If it doesn't have the CH2, this is phenyl.
Right, because phenyl is by itself attached to something.
Right.
Benzyl, this is the C.
The way I think of it is, I think that this should be benzyl. but it isn't. They screwed us over on that one. So I just remember that it's not what I think it should be. So we think, this is benzene as a group, we would expect it to be benzyl, but it isn't. Benzyl is the one with the extra piece on it. Yeah, that really bothers me, as you can tell.